Okay, we're going to review these. This is kind of like a repeat lesson to just kind of go over some of the facts with solving equations with rational functions. So in these notes, we get rid of the denominators and solve rational equations so that we can find where two rational functions intersect. Now, steps are, one, we get rid of the denominators, and you do that if you have one rational expression on one side, cross multiply. That's kind of an easy way, and you've done that before. And the second one, B, is if you have more than one rational expression on one side, then find the LCD of all rational expressions. And we're going to multiply all terms by the LCD. And what that's going to do is it's going to wipe out all of the denominators, and you'll have either a linear or quadratic or some other form of an equation. Then we solve for x and check for extraneous solutions. So if you look at the first type, type 1, where I have it set up, before we start, what x values make these functions undefined? So you always want to think about that first. So we can kind of say for this first one, if we run into an answer, because we might have an extraneous solution, x equal to 2 would be a problem, and also x is equal to 5. So we would look at those first and say to ourselves, well, x cannot be those two values, okay? So let's go ahead and solve this by cross-multiplying. So we get 14x minus 70 is then equal to 11x minus 22. And so then we're going to add 70 to both sides. And we're going to subtract 11x. So notice how I columnated the terms, so with the like terms. So we get 14 minus 11, which is 3x on the left-hand side. The 70s are gone. And then 11x minus 11x. And then we get negative 22 plus 70. So that's going to be 48. So that's equal to 48. And then we divide both sides. We divide both sides by 3. And we get x is equal to 16. Okay, so we have our answer there. All right? So not an extraneous solution, so there we go. All right, the next one, before we start, what x values make these functions undefined? So for this one, we're going to have to say x squared plus 4x. So we would factor out an x. X plus 4 is left. So we've got the x plus 4 in there as well. Where's that equal to 0? And that's when x is equal to 0 or negative 4. So remember that if we keep this in the back of our mind, the domain x cannot be those two values. So we'll continue on with this. So we cross multiply, we get 3x plus 12 is equal to x squared plus 4x. We've got a quadratic now. The previous equation turned out to be a linear equation. Now we've got a quadratic equation. So what we're going to do is subtract 3x and subtract 12 from both sides. So subtracting 3x and subtracting 12, we get x squared plus x minus 12. And on the right-hand side of that equation, we get 0. So as you know, this is a fairly easy factorable equation. We're looking for the factors of negative 12 that sum to 1. So you guys can probably tell pretty quickly that that's going to be 3 and 4. 3 times 4, we need to assign the negative sign, but we need the 3 plus 4 to be positive, so this is going to be like so. And so you can see we get x minus 3 is equal to 0, which gives us x is equal to 3. And then we get x plus 4 is equal to 0. We get x is equal to negative 4. So when we look at these, we have this x is equal to 3 as a solution. And we know that because the only two extraneous, this are negative 4 and 0. So now we have an extraneous solution here. So we only get x is equal to 3. So here's our solution here. Here's our solution, x is equal to 3. Okay, so negative 4 is extraneous. Sometimes we just cross it off and go like that's extraneous. I forgot the s. Okay. All right, and the next one, we can also do that by cross multiplying. When we do, we get 11x. 1 times 11x plus 8 is equal to 2x squared plus 5x. We're going to subtract 11x from both sides. And also subtract 8, because we recognize that this is a quadratic, so we need to set it to 0. So we have a 2x squared minus 6x and then minus 8. So the first thing you want to do, always remember the first rule of factoring is, don't talk about factoring. No, I'm just kidding. But the first rule of factoring is to factor out a greatest common factor if you can first, and sometimes it makes your work a lot easier. So we're going to factor out a 2 minus 3x and then minus 4. Okay, so we factored out a 2 from each term here. We had a 2 here, a 2 times 3, and a 2 times 4 here. So Now, all we have to do, we can leave the 2 there. Sometimes people go like, well, maybe the 2 is, what happened to the 2? You can divide out the 2 on both sides, but we'll just leave it there to be a little more, I don't know, empathetic, like what happened to the 2? The 2 is still there, but it's not really going to be a factor that's going to turn the equation equal to 0. So now I just have the factors of -4 that sum 2, 3. Well, what are the factors of -4? So I have 4 times 1, right? And one of them has to be negative and one has to be positive, and that's the combination you're going to get then. So -4 plus 1. So you can see that we get x is, oh, and one thing I forgot to do when we started this is I forgot to say what the domain restrictions are. And we look at the original form and we can see that, well, 2x plus 5 can't equal 0. 2x plus 5 cannot equal 0. So that would mean when x is equal to -5 halves, -5 halves. And so our solution can't be that. And then the other possibility is 11x plus 8 can't equal 0. So that's going to be when x is equal to -8/11 when you solve that. So those are the only 2 possibilities. We don't have those solutions, so we could say x is equal to 4 or x is equal to -1 here. Okay, so these are our 2 solutions here. Okay, all right, so as we're moving right along, okay, then we have this next section with solving by using the LCD to eliminate denominators. So in the first video that you were watching, we cross-multiplied. You've been doing that since probably 6th grade or so when you want to solve an equation that is that has ratios. A ratio is equal to a ratio, cross-multiply and solve them. So it is called a proportion when you have a fraction equal to a fraction. So you've been used to doing that. Here what we're going to do is we're going to find the LCD. And one of the things that I started practicing with students is we actually make the denominator the same for all of the terms that exist in the fraction. And it may be a little easier. I have both ways I'll show you, but that's what we're going to do here, right? So what we get, we can see when we multiply these together, we have 2, 3, 4. That looks like a 24, right? 2 times 3 is 6, times 4 is 24. Okay, now we're going to clear the fractions here, just because it will be a little bit easier. So you can see with in the highlighted in yellow, I have the original equation. And then I've got, I'm multiplying by the missing factor of the LCD. The first term has 3 and 4 missing. The second term has 2, 3, and 4 missing because it's just a 5. And then on the right-hand side of the equation, we have the 2 and the 4 are missing in the denominator. And then we have the plus 3/4. So what this is going to do, it'll show you with numbers. It's not necessary to solve this equation by using this method, but it certainly shows you with numbers instead of variables how this works. So on the first equation then, what are we going to have? But we're going to have 3 times 4. So the first term is going to become negative 12x. I'm going to put the x in the numerator, and then that's going to be over 24. Plus, then we have, notice I have all the terms there. 2, 3, and 4 multiplied by all the factors. 2, 3, and 4 multiplied by 5, and then in the denominator will be 24. So we have 24 times 5 in the numerator. I'm going to put the 24 down here first. And then 24 times 5, 24 times 5 would be then 80 plus 20 is then 24 times 5 is 100 plus 20, 120. Okay, 120. Okay, and then that is equal to then over here, we have 2 times 2 times 4, which is 16x. I'm going to put the x up in the numerator. And then in the denominator, we have 3 times 2 times 4, which is again 24. And then on the right-hand side, we have 3 times 2 times 3, which is 18. 18, and then at the bottom, we have 24 again. So you can see with numbers, we don't have any variables in our denominator at all. But with numbers, it may be a little bit easier to see why this works so well. And we're actually multiplying each term by the missing factors of the LCD over itself, okay? So now what we're going to do is we're going to take the whole equation, the whole enchilada, and we're going to multiply both sides, and we're just going to write it one time over here. But essentially, we're going to multiply both sides of the equation by 24. Now, I could write this out really quickly. Let me dupe this very quickly here. What this means to do when you multiply both sides of an equation by 24, you're going to distribute that. So this 24 is going to multiply times each factor, right? It's like throwing in a times 24. And that'll cancel with the denominator, like so, right? So they all cancel. What you're left with then is just the numerator. I'm going to put this right here. And you got to remember, you're not multiplying one side by 24. You're multiplying both sides of the equation by 24. So now you get this, negative 12x plus 120 equals 16x plus 18, okay? So the denominators are completely gone. Now you have a linear equation. Right? So all you have to do now is just, oops, I think I might have duped something there that I did not mean to dupe, but that's quite all right. Okay, so now with this, we'll solve this, and we're going to add 12x to the left, add 12x to the right. I'm just trying to double check, see where I am, because I think I kind of lost my page. I'll take a pause after this problem itself. So, and then I'm going to subtract 18 from the right, subtract 18 from the left. And so on the left-hand side, that's going to give me how much 120 minus 18 is 102 is equal to, we have a 28x on the right. And so we're going to divide both sides by 28. So we get x is equal to 102 over 28. Okay, and if I look at my equation, I don't have any denominators to worry about. So my solution then would be 102 over 28. Now, I'm just going to go through here because it seems like I lost my page, and I'm not quite sure where that went to. But okay, I got it back now here. I'm not sure why they just disappeared, but okay, there's our first problem. Let me pause. I've got to reflect on this because I'm throwing these out as quickly as possible and I didn't want to take too long. So I'm going to pause and stop right there.